Elementary Science Class 6. Fun with Magnets. Maisie, have you ever wondered how magnets work?
Yes, I have. They're fascinating.
Did you know that magnets come in different shapes and sizes, like bar magnets, horseshoe magnets, and cylindrical magnets?
No, I didn't. That's interesting.
Magnets have been around for a long time. In ancient Greece, a shepherd named Magnus discovered natural magnets when his stick got attracted to a rock on the mountainside.
Wow, I didn't know that.
Nowadays, magnets are used in everyday objects like stickers, pin holders, and pencil boxes. They help keep things in place and make our lives easier.
That's cool. How do magnets work, though?
Magnets have a north and south pole that attract or repel each other, depending on their orientation. This property is called magnetism.
I see. Can we do any fun activities with magnets?
Yes, we can. We can make a clip made of iron float in the air by using a magnet inside a cup and a short thread. It's like magic. Magnetic and non-magnetic materials. Have you heard about magnetic and non-magnetic materials?
Yes, I have. It's an interesting topic.
We can walk in the footsteps of Magnus and test various objects of day-to-day use with a magnet to observe which objects stick to it.
That's a great way to understand the concept of magnetic and non-magnetic materials. We can also rub a magnet in the sand or soil to see if there are iron filings in it.
Yes, and we can compare the amount of iron filings found in soil from different parts of the country.
That's a brilliant idea. It will help us understand the distribution of magnetic and non-magnetic materials in different areas.
Exactly. And we can prepare a table in our notebook to record our observations.
That's a good way to keep track of our findings. We can also note the materials that are attracted to a magnet and those that are not.
Yes, materials like iron, nickel, or cobalt are magnetic, whereas materials like soil are non-magnetic.
Yes, materials like iron, nickel, or cobalt are magnetic, whereas materials like soil are non-magnetic.
Poles of magnet. Magnetism is a fascinating topic that has practical applications in our daily lives.
Iron filings get attracted to a magnet when rubbed in the soil.
Yes, and the iron filings are attracted more towards the region close to two ends of a bar magnet. Poles of a magnet are said to be near these ends.
That's interesting. Can you show me an experiment to illustrate this?
Sure. Let's spread some iron filings on a sheet of paper and place a bar magnet on this sheet. You'll observe that more iron filings get attracted to some parts of the magnet than others. You can also do this activity using pins or iron nails in place of iron filings and also with magnets of different shapes.
Wow, that's amazing. Can you draw a diagram to show the way iron filings stick to the magnet?
We can bring a few magnets of different shapes to the classroom and check for the location of the poles on these magnets using iron filings. Finding directions.
How did people used to find directions before GPS?
Well, they used magnets to find directions. Magnets have been known to people from ancient times, and they have many properties that were known to them.
Really? I didn't know that. Can you give me an example?
Sure, there's a story about an emperor in China named Huang-ti. He had a chariot with a statue of a lady that could rotate in any direction. The statue had an extended arm that always pointed towards the south, and by looking at the extended arm of the statue, the emperor was able to locate directions when he went to new places on his chariot.
That's fascinating. How can we make our own direction finder?
We can take a bar magnet, put a mark on one of its ends for identification, and suspend it from a wooden stand using a thread. We can then rotate the magnet and mark the position of the two ends in its position of rest. The magnet will always come to rest in the same direction, which is the north-south direction.
That's amazing. What's the significance of the north and south poles of the magnet?
The end of the magnet that points towards north is called its north-seeking end, or the north pole of the magnet. The other end that points towards the south is called south-seeking end, or the south pole of the magnet. All magnets have two poles, whatever their shape may be. This property of the magnet is very useful for us, and travelers have been making use of it for centuries to find directions.
Wow, I had no idea. Is there a device that uses this property of magnets to find directions?
Yes, there is. It's called a compass. A compass is usually a small box with a magnetized needle that can rotate freely. The compass also has a dial with directions marked on it. The compass is kept at the place where we wish to know the directions, and its needle indicates the north-south direction when it comes to rest. Make your own magnet. There are several methods of making magnets, but the simplest one involves taking a rectangular piece of iron and moving a bar magnet along the length of the iron bar in the same direction about 30 to 40 times. This process magnetizes the iron bar, and you can check if it's a magnet by bringing a pin or some iron filings near it.
That's fascinating. What about compasses?
You can magnetize an iron needle using a bar magnet and insert the magnetized needle through small pieces of cork or foam. Let the corks float in water in a bowl or a tub. The needle should not touch the water. The needle will always point in the same direction when the cork stops rotating, indicating the direction of the magnetic field. Attraction and repulsion between magnets. When two similar poles of a magnet come together, they repel each other. When two opposite poles come together, they attract each other.
That's amazing. How can we observe this property of magnets?
We can take two small toy cars and place bar magnets on top of each car, fixing them with rubber bands. We can then place the cars close to each other and observe their movement. We can also suspend a magnet and bring one by one the poles of another magnet near it.
That sounds like a fun experiment to try. Are there any precautions we should take when handling magnets?
Yes, we should keep magnets away from cassettes, mobiles, television, music system, compact discs, CDs, and the computer. Magnets lose their properties if they are heated, hammered, or dropped from some height. We should also store bar magnets in pairs with their unlike poles on the same side, and separate them with a piece of wood, while two pieces of soft iron should be placed across their ends.